Hello everyone, I'm Silvia Marconi from the Department of Methods and Models for Economics, Territory and Finance of Sapienza University of Rome, and in this short video I'll show you my current research. A CNN-based approach to space filling curves classification for stock market movement prediction. This work is in collaboration with Barbara Vantaggi from the same department and Vittoria Bruni and Domenico Vitulano from the Department of Basic and Applied Sciences for Engineering of Sapienza University of Rome. Stock market movement forecasting consists in predicting whether stock prices will rise or fall in the near future using historical data. That is a subject of great interest in the economics field. But financial time series are nonlinear, noisy, and stationary signals, since the stock market is influenced by various complex and unpredictable factors. This makes forecasting market movements a very challenging task. We try to accomplish this task with a supervised learning approach to predict the average movement over the next 10 days, exploiting the high image classification capabilities of convolutional neural networks. We use intervals of 64 days as input for classification. Regarding labeling, if the mean value over the following 10 days is greater than or equal to the mean over the last 10 days of the interval, the label is up, otherwise the label is down. Predicting raw data leads to poor accuracy, since the CNN is confused by oscillations. And then we apply a Gaussian-weighted moving average filter to enhance the model ability to capture the signal trend. If we classify the intervals of the smoothed signal, the red line in the figure, the performance significantly improves. But unfortunately, this approach cannot be applied to the test set, because for test intervals, future values for smoothing evaluation are not available. And so we have to smooth the signal up to the right edge, but this lowers accuracy, as the resulting signal, the black line, does not account for what happens in the future. To address this problem, we predict the original signal beyond the right edge with the vector autoregressive model and restrict the smoothing of the predicted signal to the interval. In this way, the obtained signal, the blue line, better resembles the actual trend, resulting in higher accuracy. Then we transform one-dimensional signals into 8x8 matrices following the Hilbert space filling curve. Finally, we classify the resulting grayscale images with a customized CNN, consisting of 3 convolutional layers, followed by ReLU activation and dropout layers, 2 fully connected layers, and a phyla classification layer. Now let's see the experimental results. For our experiments, we used the daily adjusted close price of the Standard & Poor's 500 index, and we applied a sliding window approach, considering periods of 8 years. The first 6 years are used for training, the following year for validation, and the last one for testing. The classification is repeated 7 times, sliding 1 year at each step, covering the period from 2010 to 2023. If the CNN is trained and tested with intervals of the raw data, the mean accuracy is about 66%, as expected. If we repeat the experiment with the intervals of the smoothed signal, we obtain high performance, with a mean accuracy exceeding 91%, confirming the potential of CNNs in classifying these image-like representations. But as we have already pointed out, these test intervals are not suitable for predicting purposes. If we classify the smoothing of the right truncated signal, we obtain about 72%. If we apply the strategy to predict the signal before smoothing, the mean accuracy increases to approximately 74.5%. That is comparable with what is found in the literature. The overall procedure is still work in progress, but we are confident that we will improve our results. Concluding, in this work we performed stock market movement forecasting using raw historical data without extracting specific features from the signal. As we saw, the pre-processing step is crucial to improve accuracy. So in future work, we plan to explore alternative smoothing techniques and adapt them to the variability of the signal. Additional research will focus on identifying hard-to-predict intervals and improving their classification using tailored strategies. We'll also extend our method to other stock market indices. That's all. Thank you for watching.